Welcome back, my friends. This is Karthik Nagarajan, your technology buddy. Because I don't want to take a lot of your time, let me be very precise. First thing to say is, you all know what is AI, and let me just start with a few terminologies and then we'll go into the details. Today's video I would want to discuss about RAG, the Retrieval-Augmented generation, and then I want to now go into the LangChain, the Spring AI, and then from there, what are the similar tools and what we can use them for and things like that. Because anything in this AI world is possible only through an LLM. Because let's go into RAG. What RAG is Retrieval-Augmented generation. What is Retrieval-Augmented generation? Practically speaking, I have implemented few models and I have implemented few applications through RAG. So that made it possible for me also to do a brief research, not brief, a research, very detailed research for past almost like more than a year. And then I had to implement some of these applications, what I had to implement. Let me just give you what I did. RAG is a framework that allows you to now retrieve all the data from your data sources, from your APIs. Now, when you are now pulling data from your data sources, you now have two things. Assume this way. I now speak. Tell me what is today's plan. Let's say this is a question that I'm giving it to an application that I have used RAG and my own data sources, because the data source is going to be my data. It is not the data in an LLM. Let's say in the cloud or something. Let's say the data is my data. Assume my data. I have all my activities, I have all my journals, and I have all my documentations. Now, that is a data source. Yeah, let's not worry about whether it is a DB, whether it is a document format, whatever it is. That's for another session. Now, let's assume that is the data source from where I have to now ask this question to get an answer. How will I do it? Now, these data sources are first to be converted into what we call vector form. The vector format of the data is stored in the vector database. Now, you now look at the technology and then the tech stack and also the libraries, tools for you to convert. I will just give you a brief about what is RAG, how can you now build an end-to-end system with using RAG as an AI application. So, your data source, from where you now convert the data source into a vector database. From the vector database, you create embeddings. Yeah, embeddings is what you need from this. Okay, it's a snippet of your database or your vector data that you are going to pull and now combine it with what we call through the RAG with the LLMs. There are a lot of free LLMs, llamas, what and what. Now, even the latest LLMs are faster than the traditional LLMs. So now the question comes in, I have a data source, I have converted into a vector database. I have now started pulling my data, what I call embeddings. Now I am embedding it into what I would say is an LLM integration. Now through this both combination, what we call RAG and reverse RAG. There are both options, RAG and reverse RAG. Means either you can retrieve the data from your data source and then from your embedding you can now allocate, combine it with an LLM integration, then you get an output. Now this output, the reason why we are going through an LLM, simply speaking, embedding is there. Now that embedding, what we are going to get in, the vector format is going to be very different for us. It is all going to be, binaries and things. We cannot understand what is a vector format. So when the data is pulled out, after the vector format and embeddings, as embeddings, you cannot just export it into an output that a layman can understand. So a human understandable format for which we have to convert the data embedding, for which we need to use an LLM. So that is where the integration with LLM comes. So what we have is, let's just review it once again. Data source, plain text or human understandable data source. That data source is now converted into vector. Now vector to embedding. Now embedding combined with what we call the LLM knowledge for the LLM to convert the data what we have finally brought out into a NLP, natural language protocol. So for us to do RAG then NLP, in between we have the LLM. So what we get out is a clear, human understandable format. This is in short what is RAG, what is an NLP, what is an LLM, all these are okay. So now when we look at this process, we have already completed what we call RAG. Now let us go into what we have. How can we do RAGs? Because the LLMs are not so easy. In Python, we have LangChain. Now the same way when we look at in Java, let's say Java and Spring Boot, there is another library called Spring AI. You can now do a deep research on Spring AI, LangChain, and then you can now compare what they do, what is RAG, and then what is now NLP, all those things. And the next thing is what are the libraries that you can, it makes it easy for you to integrate the whole ecosystem and bring out an AI application. So when we look at the LangChain is an open source framework for LLM powered applications, mostly used with Python and JavaScript. Connects AI model, all the AI models with documents, APIs and tools, as we have already discussed. Used for chat with documents. RAG can, that is the same thing that we have also been discussing about the Notebook LM. For example, assume what is Notebook LM. Notebook LM is just simply a RAG based LangChain sort of a framework that we will also have a discussion later in another session. And then these are used for the LangChain is now, it converts the whole. Now assume we have discussed the whole framework or the whole flow, how you can now take a data source and make sure it now is, you gain insight through AI from, from the all these tools what we have discussed. Fine. Now the question is, how can we make it agentic? There is another video that I have posted for an agentic approach, MCP, agents, ADKs, the agent development toolkit. MCP is model context protocol. Model context protocol is now again an integration, an orchestration. Now, what is a model context protocol? All those things I've discussed in the other videos. Let's not dive deep into that. Let's focus purely on, you can use multiple agents. So now the RAG comes in, and with the RAG agents, you now can use LangChain to now get your output. And then this is used for multi-step AI workflows, LangChain. And LangChain is very popular for startups and fast implementations and experimentations. Now, the next thing is Spring AI. Spring AI is a similar library, but it is in the Java and the Spring Boot framework. Now, when we look at it, it is a framework. It's an AI framework designed for Java and Spring Boot, built for enterprise and large-scale systems, follows Spring patterns like beans and dependency injection, works with chat models and embeddings, supports vector databases and tool calling, ideal for banks, enterprises, and legacy Java systems. So this is basically about the Spring AI. Now, when we look at the other frameworks, I don't want to compare what is this LangChain, Spring AI, all those things you can do. Go in and dive deep into that, because every one of us are looking for our own questions. Not always that I am looking for the same question as you are looking at. My question in this pool of knowledge is different for me different for me when I compare it with yours, because my point of understanding is totally different from your point of understanding. So I don't want to tie your thought flow into my flow. So I'm just leaving it as loose ends for you to go and do your own research. The other AI frameworks for RAG and documents, we have LlamaIndex for document ingestion and indexing. And then when ingestion is just like pulling in all those and then converting it into the vector format and then creating FLIS database, all those things. That is the embeddings and all those. Now the Haystack, the next AI framework for RAG and documents is Haystack. Haystack is mostly used for search-driven question answering. And then the other frameworks, agents and workflow-based frameworks, what we have is LangGraph for stateful long-running agents, Semantic Kernel from Microsoft, that is mainly for orchestration, and AutoGen for multi-agent conversations. Then CrewAI for role-based AI agents. CrewAI is for role-based AI agents. Now, low-code and visual AI tools, what we have are Flowise for drag-and-drop AI workflows, and then N8N for automations with AI steps, and then Zapier, some call Zapier AI for business process automation. And now when we have cloud and managed AI platforms, that people can now look through are Google Vertex AI and Amazon Bedrock, and then Azure Copilot Studio. So now when we look at, these are my research output which I would want to bring it for you all, so that you understand and you can do your researches, and then you can find what library that you need to use for your purpose and your applications and your workflows and your business and your project management or IT management or automation of your whole IT department, automating all the security managements, automating all, let's say, visitor management, automating the business workflows, automating IoTs. All those things are possible through these, because that's very key. I've given you the framework. Now you are open. Now your mind has been opened up, saying, yeah, this is all AI. AI is not what to say, it's not a tough thing. It is not a strange thing. Now, when to use what? I'll just give you a list of items from my research also. Build fast AI apps. If you want to build fast AI apps, LangChain is the best thing. If you want Java or Spring Boot projects, Spring AI is the best. Heavy document intelligence, use LlamaIndex. Multi-agent systems, use AutoGen or CrewAI. Now, enterprise workflows, Spring AI or Semantic Kernel from Microsoft. No-code AI workflows, use Flowise or N8N. N8N is becoming so famous nowadays, and there are a lot of discussions going around it. So you can also look through other videos from other friends in the YouTube and social media platform for you to know what N8N is. N8N, if you want any of the particular topics from these discussed items for me to dive deep into, please comment, so that I will be able to do my research more on it, and then I will be able to come back to that topic. I'll definitely make sure I'll do my research on what you are requesting for, and then we have a lifetime to think through and learn from, because AI is not going to stagnate, or AI is not going to just grow like a kid, because it is growing exponentially in technology and opportunities and possibilities. So we have a lifetime to research and come out with whatever we need. Thank you, my friends. Thanks a lot. Cheers. Bye. I'm happy that you have all spent your precious time with me. We will meet each other at our next session sooner. Thank you. Bye. Cheers.